If we look at sequences and the corresponding series, we might wonder if the series are converging, right? So let's highlight this through some examples. And the first example is deals with the sequence that we've seen in the last movie and the last clip, and that's the sequence where we have as nth element 1 a half to the power n. So we found for the partial sums, we did use the explicit formula, right? So Sn is the nth partial sum equals 1 minus 1 over 2 to the power n. So if we want to calculate the limit of the partial sums, then we take this formula, and we clearly see that 1 over 2 to the power n, this term goes to 0, so the total goes to 1, right? So we just can take the limit over 1 minus 1 over 2 to the power n, and its limit is 1. So here we say that the sum over an is convergent, right? So we have a converging series, and it has as sum, the sum is just the limit of the sequence, and the sum equals 1. Okay, now more interestingly, here we got a formula, but now let's look at an example where we don't have an explicit formula for Sn. So look at the harmonic sequence where the nth element is 1 over n. Then if we look at the partial sums, we can clearly conclude that we keep adding up positive numbers. So Sn is at least increasing, but still we don't know if its limit exists, right? So we keep adding up numbers, but these numbers are getting smaller and smaller since the limit of an equals 0. Okay, so we could just gonna calculate some partial sums. S1 is equal to 1, clearly, right? So it's just the first element. And S2 equals 1 plus a half. It's the second element. And now let's make a jump. We know that S3 is larger than S2, but S4 is even larger than S3. So let's have a look at S4. So what we see here, that it's S2, of course, plus third element 1 over 3 plus the fourth element 1 over 4. Okay, but now we see something interesting, that we keep here adding up two numbers relative to S2, and 1 over 3 is larger than 1 over 4. So what we see here, that this is larger than 2 times 1 over 4. So 1/3 plus 1/4 is larger than a half, right? So S4 as a total is larger than 1 plus a half plus a half. Okay, we keep doing this. I'm just gonna collect information about S with an index which equals a power of 2. Let's do that for S8. Then maybe you see some logic behind the reasoning. So here we get 1 plus a half plus 1/3 plus 1/4, right? So, and we already seen that this term is larger equal than a half. But now we keep adding 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. And what we see is this one is larger than a half. But now focus on these four terms here. These are all larger and equal than 1 over 8, right? So 1 over 5 is strictly larger than 1 over 8. So what we get here is more than 4 times 1 over 8, which is a half, right? So what we can see here, that these four terms are larger than a half. So S8 in total is more than 1 plus a half plus a half plus a half. So it's more than 1 plus 3 times a half. Well, maybe now you see the logic. We just keep continuing with partial sums s to the power n with an index equal to a power of n. And what we see is that using the same logic, we can show that s to the power 2 over n is larger than 1 plus n times a half. So when n increases or goes to infinity, we see that n plus 1 plus n times a half goes to infinity, which means that the partial sums are also increasing and going to infinity. Yeah, so even though, so we have a limit of n to infinity as n equals infinity, which means that the sequence of partial sums are divergent. Okay, now another example. So we've seen if you keep adding up smaller and smaller numbers, that it may still hold that your sequence of partial sums is divergent. So this is not enough to guarantee convergence. So now let's consider the example we gave last time, and that's the alternating series where we have minus 1 to the power n divided by n, where n ranges from 1 to infinity. Basically what we see here is, here you see a plot of the partial sums Sn, right? So we start with minus 1, then we jump up with a half, right? And then we get minus a half, then we jump down 1/3, and then we jump up with 1/4, we jump down with 1/5, and you see that you get this zigzag type of graph of the partial sums, and it seems to be converging. And what we later see is that it's actually converging, and that's what we'll prove. And basically it is that the jumps have a positive sign and a negative sign. Jumps go up and down, but the size of the jumps are dampening, and this causes the partial sums, the sequence of partial sums, to converge.